Hey everyone, it's a beautiful day out here in Boston. I actually just got back from the beach, but we've got some video games to make. So in this video, we're gonna wrap up most of what's left of our Pokemon game. I think we're gonna add some audio to it, maybe add some ambient sounds and everything as well, and try to get some more atmosphere going in our game because audio is a big part of a good game. So anyways, let's get to it. So first off, let's maybe start with getting rid of the additional Pokemon that we used to test the game in the latest video that we did. And then we're going to have to import some audio. Now I'm going to provide these files on the class website if you're in my class. Otherwise, you're going to have to just find them yourselves online. I recommend freesound.org, which is a website where you can download a lot of free sounds from, as the name implies. And the only thing you need to be really mindful of is that every sound on here comes with a license, and the license depends on the author. So it can be that you need to attribute, or that the Creative Commons 01, that you can just use it for sampling and so forth. But there's tons and tons of great audio files on here that are sometimes already been pre-processed and everything. So it's a pretty good tool to have in your toolkit as a game developer. Now I made a folder for the audio in my assets as well while I was talking, and we can pretty much just grab all the files and just drag and drop them right in there. Give it a second. So they're all WAV files or WAV files, which is a pretty standard audio format. I think there's other formats like OGG or MP3 that will probably work with Unity as well, but usually for a game I just use a WAV file. It takes a second to import this, so I'm just going to fast forward. And there we go. All right, so with that, I'm going to maximize Unity again. And the next step that I'm going to do is I'm going to do some prefixes and rename all of this. Again, probably something I want to fast forward real briefly. There we go. Now you'll notice that I have files that are labeled as SF, which I use for sound effects. And then there's one that are SD, which I use for soundtrack. So these are more ambient and music. I mean, I guess ambient can be sound effect as well. It really doesn't matter. You do it whatever you want. For me, it's mostly just the sound effects are going to be addressed in code a heck of a lot more. While ambient is kind of, if the game would have music playing in the background as you played, which a lot of games actually do, it's a longer file, so that's why I tend to go for SD. You can listen to them by pressing the button here in Unity, and let me make sure that my desktop audio is on. So, and this goes on for quite a while, so that's the ambient sound that we're going to be playing. I'm going for a more realistic vibe than a video gamey vibe. We have a theme song for the main screen. So that's a combination of the original Pokemon theme and Duck Hunt. And then we have sound effects for footsteps in the grass. And I picked some that were really long grass. I got footsteps for sand. Now, if you start searching for your own files, these kinds of sound effects are usually referred to as Foleys. So Foley. So typing in Foley in a search engine for this can be very helpful to find these kinds of sound effects. Pokeball collision. Pokeball escape. And again, these come from Freesound, most of them. And then for PsyDuck, I got some off of YouTube from somebody who was doing impressions of PsyDuck. And so anyways, it's not perfect, but it's good enough for our purposes here. So one thing that I'm going to do next is I'm going to force all these files to mono. Most of them are already going to be mono files anyways, because you want your sound effects for a video game typically to be mono, not stereo. We can control the stereo effects through code whenever we want to, but a lot of the times in a game, we're going to do spatialized 3D sound. So having stereo on your sound file already as well is just going to make things a lot more confusing. There are other options like loading in the background and ambisonic and everything. We're not going to go too much into that, or the way they're compressed. Like, we can leave all that stuff to default, but for all these files, what you want to do now is make sure they're forced to mono and that they're normalized. So normalized will make sure that the volume, the level of all the sound waves is pretty much the same. Like, Unity doesn't ask for a certain threshold. Usually I normalize at minus 6 decibels, but it doesn't matter for Unity. So you just want to turn all of those things on, and I'm going to do that and fast forward. All right, so once you've done all of that to your files, we can pretty much start adding them to the scene. So I'm going to open up my start menu, save, so we don't lose anything. And we could add the audio source to whatever we want, whether it's the menu or the camera. I honestly don't think we even need a camera for this, but so what we can do is create an audio source class and add it to it. And it will ask for an audio clip. So this is our start menu. So we can go grab that SpyDuck theme that we want, drop it in there. We can put that on loop because we want to keep it playing. And then there's a bunch of options that you can change if you're familiar with audio files. For stuff, I mean, a lot of the times people will, if it's 2D sound, people will just attach it to the main camera. So, you know, actually we could just copy the component and remove it here and just do it that way. But I don't think it actually matters at this point. It should be, yeah, it looks like, oh well, I'll just add it again. But yeah, so a lot of the times if you're doing 2D sounds and you don't want it to be spatialized in 3D, you can just connect it to the main camera. So I'll just put it there because that's an obvious place to look for it. And then we'll turn on the loop. And there's lots of other things that you can attach to it and set up and 3D sound and mess with the pitch and the volume and everything. I think keeping the volume at 1 should be fine. So let's see what happens when we press play and see if everything is working. So yeah, there you go. And since this camera that we attach to no longer exists when we go to the next scene, it'll immediately stop when the next scene gets loaded, so we don't have to worry about it whatsoever anymore, and we can go back to sample scene. So that's how it's pretty much done. You create an audio source, and then you can hook up audio files to it, and you can set loop on the audio source or mess with the pitch and all that kind of stuff. Now, if you want to do a 3D, if you want to do a 3D sound, you can actually talk directly or send code directly to the audio source class. So let me open up one of the script files here. I think a good one would probably be the player controller. Or actually, we're going to work with sound on the Pokemon first. So let's do the Pokemon controller. And yeah, let's load that in. So first off, with everything loaded in, I want to set up some variables like we usually do. So, and we can serialize them because we want to be able to edit these in the editor itself. So we're going to make audio clip variable. So an audio clip goes into an audio source like I just demonstrated. And we're going to call this one Psy sounds. So the sounds that PsyDuck would make. And we're also going to make a couple more of them, audio clips. One is going to be for the grass sounds because we want PsyDuck to be able to walk on the grass. And we want one for sand sounds so PsyDuck can walk on the grass. So we're going to do sound effects when we're walking around. And we're going to have PsyDuck make a sound, sigh, 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 as you know, we're going around. Yeah, I think that's everything we need for now. Now, what I'm going to do is in the editor so that we have access to some audio files. Whoops, that's not the editor. That's the game hub. Here we go. So let that load for a second. So going down to my prefab for PsyDuck. Prefab PsyDuck. Right here. So now we should see Psy sounds, grass sounds, and sand sounds. Now, as you notice from the script, I turned them into arrays so that we can actually add a list of files to them instead of one file. Because for every video game that you've ever played, whenever there are footsteps, there's always going to be multiple footstep files. And usually there's also some pitch modulation going on as well, so that every footstep sounds slightly different. The better the game, the more time and effort is put into it. So what we're going to do is we're going to go to audio and we're going to make 2 Psy sounds that PsyDuck can make. And then we're going to make 4 spots for sand and grass, like so. And they can just be empty right now, but we can fill these up. So for the grass sounds, let's just grab. And that's why the naming conventions are so helpful, because you can just drag them in that way. I looked into, like, you can also just get them through code in Unity, but it's a little bit of, it's not as convenient as this method, honestly. I like this better than grabbing this type of stuff with code. And then PsyDuck, he's going to say sigh. So that's what that sound does. And he's going to say duck. And then we have one, we have a longer one, and we have one for when he's freaking out. So freaking out is probably for when he's going to be running. Yeah, and then I don't know what long does. I don't know if we'll actually end up using that, but we have one, duck, and we have one, Okay.
Sigh.
I'm having too much fun with this. All right, so then if we look at our PsyDuck in the game, it also has this stuff on there, which is obviously important because this is what it's going to run. But whenever we are editing, we want to edit the prefab directly so that all the PsyDuck that we'll eventually end up making will have all this type of stuff in them. All right, so going back to Writer then, and grabbing this here. All right, so what I wanted to demonstrate before we actually start hooking stuff up, if you want to make sound in your game and not attach it anywhere, you could actually just use the AudioSource class, which is just built in. So if you go AudioSource play clip at point, you can make 3D sound that way. So let's say we want to grab the first sound file in the PsyDuck array. Oh, not PsyDuck, it's PsySounds array. So that's how we would get the first of them. 0 being the first. Well, for this class, you need to have done an object-oriented programming class already, so I'm sure you're aware of this. So this will play the first sound in that array that we have here at the position of PsyDuck, which is 3D sound. So this is a way that you can just play stuff pretty easily, but it's not very object-oriented, I guess, because it's kind of attached. But just for the sake of demonstration, let's play it. And it's just go Psy. Oh, there you go. And it wasn't too loud or anything because PsyDuck is not, we're not literally in that same spot. So anyways, that's how you can just easily play a sound anywhere on the map really quickly, really easily. But of course, we want to use the object itself. So this is code that we're just going to delete straight up, and we're going to do things a little bit differently. And for starters, we're going to add a couple of audio sources to our prefab. So again, moving to Unity. Shouldn't have deleted the code yet. It would have loaded a bit quicker, but whatever. So we're going to add 2 audio sources. So you can kind of look at these audio sources as if they're like empty channels. Like if you're thinking, if you had a mixing desk as a DJ or something, 2 turntables, like these would be 2 channels that you can route audio through. And we can make settings to the channel by messing about with this, but we don't really have to. We just have 2 of them. They're ready. They're part of our prefab. And if we go up here, it's in there as well. So there's 2 channels. Why do we need 2 channels? Well, we're going to use one for footsteps, and we're going to use one for the vocalizations that PsyDuck is going to provide us with. Okay. So back to our code. Let's get control of them, and we're going to go as such. So audio source is going to be the data type for the class, and then we're going to call the first one Pokemon AS1, AS standing for audio source, and then we're going to have one called 2. So that's how we're going to get our 2 channels. And that's going to be pretty convenient to get a hold of everything that we need for this. And yeah, let's use these now to play some clips. So we are going to set the value of, let's see, Pokemon AS1.clip. As you can see, Ryder is filling this in for us again. So the clip that we want is one of the PsySounds clips. And again, this is just an example. We're going to grab the first one, so just Psy. And we are going to play that clip. Play. There we go. So, yeah. And if we really want to do it over and over, we can put it in the other area. But so that would be another way to get the same result where we can play the clip. Now, one thing that I want to do here is if you play it this way, it should just be 2D sound, honestly, because it's not spatialized at all. So if we open up the first audio source, which I hope is the one that I'm referring to with AS1, I think it should be. Or actually, I'm not thinking this through, because this is going to be null. Like there's nothing in here yet. So we first need to hook these up. Of course we do. So Pokemon AS1 is going to be equal to get components. We want to get an audio source, and the audio source that we want to grab is the first one, because when we do get components, it needs to be get components, not just get component this time, because there's multiples of them. So when we do get components, as you can see here, it's going to send us a generic, that's what the T stands for, a generic that is going to contain an array. So we're going to get an array with 2 items because there's 2 audio sources attached. So the first one's 0, the second one is 1. So 1 is going to be the 0, and AS2 is going to be the other one. Now the cool stuff that we can do is everything, and this is going to render a little bit again, but render. I mean, reload the script assemblies. Anything that you can see here, thanks. Thanks so much, Unity. Anything that you can see here, you can edit. So whether you want to mess with the volume, the pitch, the stereo pan, so left or right, or the spatial blend. And the spatial blend is actually super important because at 0, it's going to be a 2D sound, so completely flat. And, excuse me, at 1, I'll demonstrate that. It's going to be spatialized sound. So we want spatialized sound because we want to use these sounds to figure out where PsyDuck is at, so that if we can see him, we might be able to hear him, and it's going to make our game more fun, right? Another thing we want to do is, for those 3D sound settings, we don't want to mess with the Doppler effect. Like 1 is fine on that, nor the spread. Those are just to, make things sound slightly different. Whether you have a linear or a logarithmic roll off doesn't really matter for us. But what does matter for us is the distance with which we will be able to hear PsyDuck, because the wider or the longer the distance is, the louder he's going to be at certain ranges still. So what we are going to do, and we're going to do this through code, is we're going to set this to a lower number, but I'm going to demonstrate what happens. If you put it at 5, you'll see here in the graph that they provide you with. So this is when you're very, very close, and you'll get literally full volume. And if you're at 5, the volume will be at 0.2. So you can see how this affects... can I revert this? Oh, I guess not. Weird. Yeah, I can do it up here always, I think. Reset. All right. So yeah, but you can see how that stuff works. Like here it would be you're at 0 point something at 100, and by the time you get to 500 it will be 0. So you can determine how the 3D sound will be, how loud it will be, depending on different distances. Now this is a pretty small map. We don't even have 500 meters in here. I think it was 100 by 100 if I remember correctly. So we want to set these values to something that makes sense for the map. So what we're going to do is Pokemon AS1. We want the volume to be, my bad. We're just going to set the volume here straight up. Then we're going to do that spatial blend. And as you can see, it's all just right there in Writer. So we're going to go full 3D. So that's 1. And then we're going to set that max distance. And the max distance for this sound, we are going to put at 5 meters. Which, I played tested this a little bit. It worked pretty well. And then for the second channel, which is going to be our footsteps channel, we're going to have the same stuff, except our volume is going to be a lot more quiet. Like it's going to be 10%, because footsteps are not supposed to be pretty loud by any means. So that's how we are going to set up our audio sources, and now we have control of them. And what I'll do is, how about we do it this way? We'll do an invoke repeating, which I've already explained. And I'm going to make a quick method called PlayPsy, just for the sake of demonstration. Here we go. PlayPsy, and just every 1 second, and repeat it after 1 second, and then void public. You don't have to copy this because we're going to delete this. But PlayPsy. Here we go. And we're going to put this stuff in there. I mean, actually, you just need to put the play in there even. So like that. Yeah, I think this should work. I'm going to put my repeat rate at 2. All right. So when we run this, you'll see how we are routing our audio to these audio sources. Oh, all errors have to be. Okay, what did I do this time? Void public. Okay. Oh dear, this is actually quite embarrassing. Public void, of course. I really hope that as you're watching this video, like, Bob, that's not looking good. After all these videos that we've done, if that's not the case, it's fine. But I really hope it isn't, because we've done it so many times. All right, let's do play and see what happens, or listen what happens. Right? Here we go. Yeah, I can hear him. So every 2 seconds, it's repeating as I get closer to PsyDuck. Don't run! Oh my goodness. I mean, I can still hear him. So I'm going to try to get close, and I'm hoping that you guys are kind of picking this up as well. I can hear him go Psy, and I'm getting closer now. Yeah, I'm getting pretty close. He's got to be around here somewhere. He's getting further away from me. I think he's to my left. No, I hear him to my right. Oh God, he's to my left again. Where is this guy? But yeah, in any case, yep, there he is. in any case, I can kind of track him through audio now, and as I get closer, so I hope that those last two, it was clear for you all, that you could really hear how much louder PsyDuck got as I got closer to him. So I don't know if my speakers are balanced correctly. Actually, if left is left and right is right. I usually use headphones when I play video games, but anyway, so spatial sound working well now. So we can add it now and add it appropriate places so that PsyDuck, is doing what PsyDuck does. All right, so we can clean up our code here and get rid of this bit because we don't need that. And actually, I am gonna create a method for playing sounds. So I'm gonna call it play sound. Okay, and we're gonna use this for a state machine. So we're gonna just call the method whenever we want a sound play, and we're gonna use this to make sure that the right clip is going to be used and add some randomness to it. So, because what I would really want is that PsyDuck, as he's walking around, he'll go PsyDuck, PsyDuck, like, just randomly saying duck and Psy, so that we can kind of track him using that. So our input, because it's going to be different whether we're running or whether we're chilling or if we're, for fleeing. So we're going to ask for the current state in our play sound method. It doesn't actually have to be a public one, so we can just write void, which will default it to private. So if our current state, right? If our current state is, what is it? State chill. Oops. State chill. Or our current state is equal to state, let's see, saunter. So if we're chilling or sauntering and we're calling the play sound thing, all right, then we are going to do if random, I think we already have the right one declared for random range, but if random range, and again, 1 to 10 equals 1. Let's do that. So a 10% chance, then we're gonna play something. Now let's make sure, yeah, okay, we're using the Unity engine random, that's the one I want. So we already are using that. So when this is happening, we are going to grab one of our clips. So we're going to grab this one here and set the clip to Psy sounds. And we want it to alternate between the two sounds that we have. Now, we're not going to just write, random range, because this would absolutely work. Like we could just go random.range and then go just 0, 1. Because we have two files in there, but what if at some point we decide to add another PsyDuck sign? So what we're going to do instead is we're just going to go PsyDucks or Psy sounds and just go length, which will give us the length. In this case, it's going to be a length of, it's going to be a length of 2, isn't it? Yeah, so that's something we need to be careful with. It's going to be Psy sounds length minus 1. All right, because there's going to be 2 sounds in there, so this is basically 0, 1. And if we start adding more, this will still take care of that. And then we are going to do Pokemon AS play. All right, so that's all great. And then, yeah, what are we doing then? Well, we can add it to our state machine. So I think, pretty much here in the chill. Where would I put it in the chill again? Probably a good spot would be not in the transition part, but rather at the very end, right in front of the break. So let's do play sound and just communicate. We're in chill, so that the files make sense. So play sound, stay chill. I'll take care of that. All right, and then I'm gonna do the same for saunter. So get up here and saunter. Now this is not great yet, because what's going to happen is we're running through this stuff, right? We're in chill or in saunter, whatever, and then we get in here, and then this is going to run multiple times per second, like every frame. So if we get lucky or unlucky, rather, this is going to trigger a whole bunch of time. Like if we have 30 frames per second, it's not even a high frame rate. Yeah, that means that we're getting, 3 hits off of that or something like that, or yeah. So that's not great, because that's a lot of noise. So what we want to do is we want to set something up so that we are not gonna just have it repeat over and over and over rapidly until for some reason it's not really getting that value of 1 pushed out a lot again. So what we're going to do to make that happen is we're just going to set a Boolean and take care of it that way. So I'm going to call this Boolean shut up. All right. So shut up is true at this point, and we are going to make a method called void reset shut up. All right. So let's do that, and we set shut up to false again. So when shut up is true, we are not going to play any sound no matter what we are in. So I think, where do we want to put it? Maybe still processes state. So if we are not shutting up, like so, all right, so if we're not shutting up, we do all this type of stuff, and otherwise we're just not going to do any of that stuff. I mean, I think we don't want to generate a shitload of random ranges. So, but yeah, this is looking good. The only thing is we need to turn it off, so we need to call an invoke for that, or set up a coroutine. If you'd rather do a coroutine, that's up to you. And this one is called reset shut up. And then we are going to, the time to call that, let's do a random range again. Somewhere between 5 and 20 seconds. 20 seconds is long, but like if we have multiple PsyDucks run in there, we don't want this to trigger every 5 seconds anyway. So I think the only final thing that we need to do is initialize and declare. So let's declare first. Let's say shut up is going to be a bool. Shut up, private bool probably. And I think I wrote it like so. Shut up. Yep. And then in here, I mean, do you really need to do this? Let's just go shut up equals true. So, that they don't all trigger at the very beginning of the game. And then we'll invoke it. Actually, let me just grab the reset shut up that we just wrote down here. Where is it? Here we go. All right. Now, looking at this code, I think what I want to do is I want to, here, we made a typo. So we want to check for typos. And I'm going to grab all of this stuff, cut it. So Control X. And then let's see what would be a good space on disable. So this is all still state machine stuff. Animations here. Yeah, between animations and getting the destination method, I think that's a good spot. I don't want it at the top here. Just the state machine is more important. So now let's have the entire state machine thing, which is an update. And yeah, so this should work. I think we're in a good spot. All right, so I got 1 minute to go catch myself PsyDuck. And I'm going to turn my volume up a little bit so I can hear them well. Okay, so that seems to be working well. Just following around a little bit. I mean, it could be 20 seconds until he does it again. We should have not set that barrier that high. Yeah, so he sighed again. All right, let him flee, and let's see if we can find him again. But yeah, there's a good chance we won't hear him again. But, like I said, if there's multiple PsyDucks, you don't want him to go off too often. Yeah, I heard him in the distance again. I mean, I know he's going to be around here somewhere. To my left, I think. Did he go? Well, anyways, it looks like it's working just fine. Now, as I was testing this, I did notice something peculiar about Unity. So I actually, as you can see, I've updated my code here and I turned it into sizesounds.length and I removed -1. Why did I do that? Well, if you look at the documentation here, it says that the first inclusive is the minimum inclusive, so that the first integer is min inclusive and the second one is max exclusive. So that makes a big deal because the same function, if we're using floats, will have, so let me demonstrate this. I'm just going to put F's here. Don't copy this. But if you go to max random range now, you'll see that for floats, it's min inclusive, float, max inclusive as well. So that means that the number for a float is going to be between 1 and 10, but including 1 and 10. So let's get rid of these F's so there's no floats anymore. However, for integers, it's min inclusive, max exclusive. So if let's say we write this code here. If we write 0, 1, which is literally what is happening with our current array, we are going to get 0 is inclusive, 1 is not inclusive. So this is always going to output 0 because it's max exclusive. Okay, I hope that makes sense. So when we input it this way with size length, we don't have to do minus 1 anymore, because we don't want a random range from 0 to 1. We want one from 0 to 2, because 2 as a max exclusive means that the highest number it will output is a 1. So that's something quirky about Unity that I haven't really seen in other places yet. So this needs to be size length if we want to hear PsyDuck go duck every once in a while, or rather duck. Okay, moving on. Let's implement those footsteps. So for the footsteps, we're going to need a couple of methods, honestly, because in other engines I have seen this being implemented in a pretty straightforward way, not as much in Unity. In Unity, you kind of have to do most of the heavy lifting yourself. I mean, most of it, there's some done. So we're going to make a float array, actually. That's going to be our output. It's going to be an array, and we're going to grab a texture mix. I'll explain in a bit. And our input is going to be a vector 3 for our Pokemon position. And we are going to grab our terrain, and then we can set this up. So that's what we're going to make as our method here. So what does that mean? What are we going to be doing here? What's going on? So, all right, let's clear. Oh, geez, do I have a error? What did I do wrong here? So get texture mix, vector 3, public float. I mean, I think all of this looks pretty straightforward. What's going on? Remove unused method. Yeah, no, I mean, that's fine. Oh, I see what's going on here. So make method return void. Okay, so I need to put the return in or it's not doing anything. So we're going to remove this code anyways, but let's make sure that we are returning something, because otherwise Unity won't compile, which is a little bit annoying, but we're still not. Oh, geez. Okay. Let's do an array of 2 floats. Seriously, Unity, this is just being really annoying and obnoxious. Come on. All right, so let's compile this now. Thank you. So yeah, in case that wasn't clear what was going on here, since we said we're going to output a float or we're going to return a float, we actually need to make sure that it returns a float or Unity won't compile anymore. I don't think that was really necessary. But anyways, if we want to go back to the editor, I guess we're compiling a little bit. But what I actually wanted to talk about is if we go to terrain, right? Remember how we were painting terrain on, I think, what is it, this thing here? And we were painting and we used the paint texture function, and we had 2 terrain layers here, so we could add some sand like so. There you go. Let's maybe put a little bit of extra here. And we could also put some grass on there. So what we want when we do footsteps is, as I'm sure you figured out by now, we have, oh well, let me grab this thing again. We have areas where there's grass, and we want to have the grass sound when the Pokemons go in there, or when our trainers go in there for that matter. And we are going to have areas where there's sand, so we want to play the sand sound. So what we want to do is figure out what is going on. Now there's a couple of ways of doing that. And the code that we are going to be using is we're just going to calculate in relation to this huge texture that we actually hand paint in Unity, in relation to that texture, where is our Pokemon, so that we can figure out what is the blend of the 2 terrain layers that we're using, what is the percentage of sand, the percentage of grass, and then whatever is the highest, we're going to play the sound of. So that's what we are going to do in code, and it's going to be quite a bit of code. So yeah, let's just get to it. And I'll explain as I go along. So we're going to start with a vector 3 for the terrain position. And that is going to be equal to terrain transform. Oops, messed that one up. Transform, yep, dot position. So it's the position of our terrain, right? And then we're going to get one for terrain data. So that is one of the classes that stores the height maps and the mesh positions and all sorts of stuff that we need, and the texture alpha maps. And that's really what we need, because the different textures that are painted within the terrain, the alpha determines how much of a specific, well, whether it's grass or sand, material type in this case, texture is actually coming through. So that's the alpha. So that's going to be relevant for us later on. But right now we're going to make some terrain data variable called, terrain data, or data, I don't know. All right, So that's our first thing. Now, next what we want to do is we want to get the position of our player in relation to the alpha map of the terrain. Like I said, the alpha map is what stores, which is painted in a certain point of the terrain. So I'm going to do map position X, and that is going to be, we want an integer, and we're going to have a whole bunch of stuff going on here. So I'm going to start with making sure that we are making an integer. So we're going to round the floats that we are going, because we're going to do divisions and stuff. We're going to round them to an integer. So anything moving forward now is going to be integers. And we are going to grab our Pokemon position, the X of our Pokemon position rather, minus the terrain position. Also the X, where is it? Here we go. So yeah, we're going to grab that first, and then we're going to divide it by the terrain data. Oops. So terrain data's size on the X as well, times the terrain data alpha map width. All right. So if we do all this, and let me make this a little bit bigger so it's easier to see. Okay, let's bring it back up and hopefully it doesn't get cut off anymore. Or rather, if I just, because I'm not going to be using this right now anyways. Here we go. So it's a little bit easier to see what we were doing, and it's just all in one line. So the map position, so this is the relative position of our player in relation to the terrain data times the alpha map y. So like, yeah, that's how you can get that. It took me a little bit of figuring out to see how I could actually get there without reading the documentation. I don't think, it's too relevant right now to go into total detail on why these things are the way they are, but that's how it works out mathematically. And in the meanwhile, as I was talking, I'm going to update this to the Z or the Z as well. So with the Z, just copy paste, replace the X's with Z's, and then height instead of width. And this will give us the position of our player. You know what? Since in case at any point you want to debug this, position of player in relation to terrain alpha map. All right. So just so you know, in case you want to debug it. So what we're going to do now is we're going to make a 3-dimensional float array. So this is like an array in an array in an array. It's kind of like an inception thing. Okay. And we're going to call that one splat map data. And it's going to be equal to terrain data dot get alpha maps. So what get alpha maps will do for us. Can I get the let me just write it first. Get alpha maps. So what it will do is it will return what the alpha map is at a certain position given the width and the height and the X offset. So it will tell us how much of a percentage of each terrain layer, whether it's sand or grass, is available at a certain map position. So to do that though, it needs to know where we are on the map. So that's why we calculate these map positions. So our player in relation to your map is going to be in these positions. There we go. And the width and the height is just going to be 1 pixel. We just want to know one specific pixel. Let's not make this overcomplicated. So what our splat map data will actually be is it's going to store first, you're going to have what's going on the X. That's our first one. Then the next dimension is going to be the Z's. So, we know where we are on the map. And then we're just going to put that alpha map data in there so that we know how much of a percentage is going on. So let me write that out to make it a little bit more. So 3D. So the first column is going to be X. Second is going to be Z. And third is going to be percentage of the terrain layers. Oh man. Layers where it's grass or sand used. All right. So that's that. So next up, we're going to create a float, a cell mix is what we're going to call it. So this is going to store literally the percentage of each texture used at a given player position in relation to the terrain. So it's going to be the same size as the third one of the. So we're kind of getting rid of the first 2 columns basically. That's what I want to do now. So I'm going to grab the third dimension of this, and we're calling this cell mix because it's the mix for a specific cell. And it's going to be a new float. And that float is going to be that splat map data, right? And we're going to get the upper bound. Now, what the upper bound does is, let me grab the documentation with, Yeah, I mean, I find it easier to explain these things as you can also see what's going on. So this will get the index of the last element of a specified dimension in the array. So it's kind of like the length of a specific dimension of the array, if you will, but it's not really the length because it's not giving you the amount of numbers. It's going to be the index. So it's easier to explain this with an example, right? So if you take this array with a whole bunch of integers, so these are, 2 is going to be at 0, and then you got 1, 2, 3, 4, 5, 6, 7, 8, 9. 20 is going to be index 9. So if you look at, you grab integers, get upper bound at dimension 0, so the first dimension, because there aren't more than one dimension in here. Like here you have 2 dimensions. So as you can see, like there's an array, an index 0, you have an array with 2 elements in there, and an index 1, you have an array with 2 elements. So this is a 2D one. This is just a one-dimensional. So upper bound for dimension 0, so the 1 would be 9, because there's an index of 9 is the last one. There's 10 numbers in here. And the first one is going to be 0, the lower one, because it starts at 0. So as you can see, the output of writing from index lower to upper would be index 0 to 9. So that's how upper bounds work, just to clarify what's going on here. And we're going to do that with dimension 2 plus 1, so that we can get all the indexes in there into our float. So all the data will just basically come over. And the reason why we need to add plus 1 is because we want to, our index is always going to be 1 lower because it starts at 0, and we kind of want a float array that is going to be, the length is going to be, the last index of dimension 2. So that's the third dimension plus 1. So that we get all the elements that are in there. So anyways, yeah, what we're going to do now, so I don't know what to write here, honestly, to clarify that. Let's just put it here because it doesn't really matter. What we're going to do now is extract all the values into that cell mix. So actually, maybe this makes sense because it's kind of about it as well. So we're just extracting here. We're just grabbing everything that's in the third dimension and making it one array, so we don't have to worry with the X and Z because it's not going to be useful for us moving on. So actually, what am I doing here? I should just type 4, and in Writer you can just press enter, and bam, Writer will take care of all that kind of stuff. The only thing it needs to know is where is the upper limit for the for loop. So our upper limit is going to be the length of our cell mix. So we're going to run through the entire cell mix. Like so, because the length of our cell mix is literally that entire dimension, and now we're just gonna copy everything over. So cell mix I is going to be splat map data, and then 0 because that's dimension 1, 0, and then the third one. Oh, why do I write? I need an I. All right, so like that, and that is going to just convert everything, and we're going to return the cell mix. Sweet. So this is just a method to grab the data. Yeah. Let me write here, converting 3D array to 1D array. All right. So it's just a little bit of data manipulation. And yeah, that will help us tremendously because now we will have a list of exactly for a specific position that our player is at. If we put in the Pokemon position and the terrain, what the mix is going to be coming out of it. And, it could be like 5% sand and 2% grass. No, actually 5% sand would mean 95% grass. All right. So what we're going to do next is the next bit and actually write a function that can help us with figuring out what the layer name is at any given spot that we are. So the footstep layer name is what I'm going to call this method, right? And again, we want to know what position our player is in because we need to feed that towards the method that we just created. So Pokemon position, and then terrain. There we go. All right, so what this method is going to do, it is going to take the Pokemon position and the terrain, and then it is going to run this thing so that we can get the texture mix so that we know it's, 5% sand, 95% grass. And then it's going to tell us TL underscore grass. That's the name of the layer that you're on. And then we can use that to figure out what sound we want to play, right? So, all right. So first off, we're gonna grab that cell mix. So float cell mix is equal to get texture mix. All right. Pokemon position and terrain. Just passing it on, honestly. All right. Now, I think it would be really helpful probably to visualize what's going on by actually showing you the cell mix. So let's just do that. The next thing we want to do is we want to get strongest texture, because we're going to compare what is the strongest at any given point, and then just output the layer name of whatever texture is the strongest. So I'm going to make a variable for that, but I'm going to put a breakpoint on there, because once we hit that, we're going to be able to see what's in cell mix. So let's just call that, and I'm just going to copy paste this here. And we're going to go to the start, and we're just going to have it happen at the very beginning. So let's start, and then we don't need to do this. We don't need to do that, because I think we've already have that stuff hooked up. Oh, maybe we don't. Oh, well. Transform position will do. And then for terrain, you can actually just do game object, I think. What is it? Game object dot get terrain. Or is it, oh no, actually it's terrain, yeah. Terrain and then active terrain. Here we go. So that will grab the active terrain from the terrain class. It's very convenient to get your terrain that way. All right, so yeah. The only thing we still need to do is let's get to the end. I just realized since we're outputting a string here, let's output a, well, I mean, it can be void at this point, honestly. And I just need to change it to string later on, or we'll get into an issue. So if I click on the bug and I press play in Writer now, the debugger will run as we are going to Unity, and this will, you know, it's attached, so it'll run our Unity editor. We'll fast forward, and there we go. We end up in the debugger, and it'll pause when we hit the breakpoint. So at this point, we should be able to just hover over cell mix. I mean, we could find it in here as well, but we hover over cell mix, click on plus, and we'll see that we have a value of 0 that is equal to 0, and we have 1 that is equal to 1. So that means that our the one that's at 0 out of them, which is, I think, grass. That's the first one in our array. I can't go back to Unity now, but I think 0 is supposed to be grass and 1 is supposed to be sand. So right now where our Pokemon is full on 100% sand. And that's actually correct, because if you remember, our Pokemon standing in the sand. So basically, our cell mix is pretty straightforward at this point, because our Pokemon's in one spot on the map, and all we retain is a value for 0 and a value for 1. And we just need to see which one is the strongest, and then which of the, if it's the 0 or the 1 that it corresponds to, and then we just return the name, whether it's grass for the first one or sand for the second one. I hope that makes sense. Anyways, let's stop the debugger here. There we go, and then stop it here as well. So, and yeah, that's how you can use the debugger. It's super helpful. So let's get rid of the breakpoint here, and let's continue. So what we want to do is we want to set an integer for the max index, 0. Here we go. And we're going to return a string. We're going to return the name. I mean, we could return the index as well if we want, like, whatever. And let's, whoops, I made a mistake there. Let's do a for loop, and the for loop is going to run until the end of the cell mix. Cell mix. So at any time, if something is confusing or you're not sure, like, what are you doing here? Like, especially when you're doing this type of stuff where you're messing about with arrays, just set your debugger up and go look what's in a certain variable. So yeah, anyways. So let's see. What we want to do is if our cell mix at the position that we are at in our loop, so it's going to be I, if that value, so you know, it's going to be a percentage if our Pokemon's at a spot where it's both grass and sand, which is like 0 point something. But if it's stronger than the strongest texture that we have seen so far, then we are going to make sure that our texture is set to that value. So strongest texture becomes the value that we just saw, and that is stronger than the other one. And when that happens, we want our max index to be this one. Okay, so I hope this kind of makes sense. You know, if you program games, you do this type of stuff so often. It's just a quick bit of code to figure out, you know, what the highest value is within an array, really. So we're just going through the entire array and we're just seeing which is the highest value. If we found the highest value, we save the index that corresponds to it, and we use strongest texture to just increase the values that we find every time we pass them. Anyways, we're ready to return our string here, I think. I hope this makes sense. If it doesn't, reach out. I mean, if you're in my class. I'm not gonna... Anyways, so max index dot name. That'll do it. So in case that's not clear, we're returning the name of the terrain layer with the max index. So, you know, if sand was at the strongest texture, max index will be 0, and this will be, no, grass, and this will be grass. And otherwise, if it was sand, it would be 1, and this would be 1, and we would output sand. So that's really literally how this function is going to work. So yeah, that should be fine. Let's actually implement it. The only thing that I'm kind of curious about is like, why is string here? Probably maybe because we're not using it yet. Who knows? We'll figure it out. Now to trigger this bit, what I want to do is I want to trigger this based off of an animation, because we want the footsteps to be timed up with the animations really well, right? So we're going to make a method for that as well. It's going to be called public, it's going to be public void footstep. Okay. And this one is going to be a lot less complicated. It's going to be Pokemon AS2, because we're going to put it towards the second one. It's going to be grass sounds. And we're going to play a random grass sound. So this is basically the exact same stuff that we have been doing with our sigh, and PsyDuck type of stuff, right? The sounds that we had earlier, the sigh sounds, that's the right term. So let's do that. Exactly the same code. So the clip is going to be set to a random one. And again, max exclusive. So we need to put the full length in the end. Super confusing if you ask me. And then we can play the clip. Pokemon AS2.play. So whenever a footstep gets triggered, we're going to set it to either grass or sand. Right now it's set to grass and then play it. So let's set it to sand as well. So when do we set it to sand? Well, if footstep layer name, we just made this thing up, transform dot, oops, oh boy. Okay, transform dot position, terrain, active terrain. And if that function is equal to, and here you just have to put in the name of your sand material. So in this case, for me, it's terrain layer sand, like so. Then we are going to set that clip, not the grass sounds, we're going to set it to sand sounds. Sand sounds. And make sure you mix it up in both spots, because otherwise it's not going to work very well. All right, and I think at the top here, I have some cleanup to do. So let's get rid of that. Beautiful, beautiful. So yeah, I think we're ready to go back to Unity unless we... Okay, so whenever this happens, I have to reboot Unity, so I'm going to do that and fast forward. There we go. And then we can go to our animations, which are under our models, animations, and we can go to the animations for PsyDuck. And it's going to be a walking one. So I'm going to bring that dope sheet in. And we've done this before. We're going to pretty much run an animation event. I mean, not pretty much, like literally. I'm struggling a little bit to drag this over, but here we go. Now, to figure out which frames it's at, we just need to add a model, preferably a PsyDuck down here. And then we can have him walk. And then, you know, it's up to you to decide when you want the sound to trigger. But I usually go when you kind of feel there's friction. So 1 here, so that would be around frame 3. And then here, like frame 14, maybe 15, 3:15. So there's only 2 steps in there. Step 1, step 2, because then we go here, and by the time we have friction, we'll be back in the beginning. So that's usually how it is for bipedal anyway. So at 3, let's put an animation event here, and we can just call this footstep. Make sure not to make a typo. And then around 15, let's do the other one. Call that one footstep as well. Now, the cool thing is, and then save. The cool thing is we don't have to worry about the other PsyDucks in there. I already tested this. The animation events that trigger from an animation are only picked up by the scripts that are attached to the same parent, it seems. So you don't have to do anything else. It should work just fine with multiple PsyDuck. So yeah, with that, we're ready to do some testing, I think. Now, before I'm actually going to show you the results, I already ran it, I admit, and I ran into two issues. The first one was PsyDuck is just saying it's not saying sigh anymore, and the footsteps were super loud. So that made me think like, okay, these audio sources aren't hooked up correctly. And lo and behold, this here, all ones that need to be twos. So they were routed to the wrong channel. And the other thing is, after I fixed this, I noticed that the footsteps were very, very faint. So I want to set it from 0.1 to 0.25, which is just a slightly bit louder. And with that, we can actually go test it. So let's go do that. All right, let's see. Yep, so I like this. So you can clearly hear PsyDuck go on the sand first and now on the grass. And the further he gets away from me, the footsteps start to fade out. Until there are none. Okay. Yeah. All right, so with that, I have some good news and I have some bad news. The good news is that you know everything you need to know to hook up all the other audio. The bad news is, though, there's still a lot of stuff to hook up. So I'm just gonna fast forward towards what everything looks like in the end. And if there are some things that I ran into that were a little bit different, I'll point them out in a bit. But at this point now, I want to invite you to just start hooking everything else up. We want our player to have the same footsteps as PsyDuck does. We want the Pokéball to have all those sounds on them as well. And we want PsyDuck to make their sounds as they are fleeing away from us. You don't have to worry about a digging sound or something, because honestly, originally when I downloaded these files, I thought like, okay, this is going to be useful. But in reality, the chances of you actually seeing them dig are just so minimal at this point that I don't think it's worth putting a lot more effort into it. So that's what I'm going to do to wrap up the video. I'll show you the results of that in just a second. All right, yeah, I think I'm happy with what we have here. So I've added all the sounds pretty much to it. So on the main camera, I think I hooked up the ambient sound. For the player controller, I pretty much did the same thing that we did with the Pokemon. I just copy pasted the code, honestly. Like, you know, we could set up a big class where we put that code on, maybe even a class that's not even using mono behavior. No, we are using mono behavior. But you know, we could set up a class to talk to so we don't duplicate our code. I think for the size of this project, it really doesn't matter to make our software architecture any nicer than it has to be. Like, this is absolutely fine because the game's pretty much done. So yeah, you know, everything is very similar to the Pokemon, honestly. A little bit of messing with the volume. I made it so that when you are running, and this code is just so nasty, honestly. Like, this really needed a proper class-based state machine, but whatever. So the volume is going to be louder when you're running versus when you're walking, which is helpful for gameplay purposes because it's easier to hear the Pokemon that way. Because there's ambient sound that's going to muck up a little bit of their footsteps as well. I messed with that volume too. Then for the Pokemon, for the running, that was actually the most interesting part of it. So I moved the play sounds to the very top so that we can actually work with transitions as well in there. Again, like, this state machine could benefit a lot from just being a class-based state machine with an enter, an execute, and an exit for every state, so that it's all just methods on a class. But yeah, and the numerator works fine still, you know, but it got a little bit weird at some point because I wanted to make sure that I wasn't repeating the sounds when I was playing them. So here I actually work with if transitions active, which doesn't really make that much sense, but it's a quick way to make sure that we're not repeating every frame. It would have actually been better if I could have done stuff exiting, so running some code whenever we are exiting a certain state, but we haven't really set anything up for that and didn't want to make it too complicated. For the fleeing sound to make the Pokemon really freak out and repeat themselves, we're working with the loops and we're setting that to true and false in specific spots where it's relevant. But yeah, the biggest change here was moving the play sound up, and that was pretty much it. So then we got the Pokéball, which was a little bit tricky as well, because even though we have we have somewhat of a state machine here and here, I guess not as nice as the Pokemon ones, but it's still not great. So what I did here was, let's see. So first in the collision, I just added the code for hitting, which is actually more of a an 8-bit sound that I found online. So I figured, I'm just going to use that. Whenever the Pokeball hits something, it's just like this 8-bit thing. It's kind of funny. You could change that with a more naturalistic, realistic sound if you want. And then we have a collision sound for when we hit a Pokemon. I added a boolean to keep track of when we want collisions to be disabled, because we didn't want that collision to just go off when it shouldn't be going off, because sometimes the ball will bounce on the floor and all that kind of stuff as well. So yeah, I put up something there so that when it's moving about. Now I did run into an issue and I didn't look further into it because I didn't think it was really worth it. But when at first I thought I'm just gonna put, for instance, my wiggle sound in the case for the wiggle and just put it in here, and it never played. And I don't know why it played. I didn't look it up. It might be because of the rigid body, like maybe that impacts the audio. I don't think it does. Maybe it's because of the priority of the audio. I didn't go back on it. Feel free to experiment with it and figure out why it wouldn't play if you want to put it in here. The quick solution for that was, and actually this needs to be deleted, I just realized, because I was just testing it out. If I put it in case 4, it'll play fine. If I could put it in case 5, it doesn't play at all. So it was interesting. But the solution for that was I wanted the wiggle to match up with the animation anyway, so there was no point in messing with that here. So I put it on the animation and I made a method for wiggle sound, which is running the wiggle sound. And then the final two are escaping and when we have a success, really. Actually, I think there is a mistake here. This doesn't need to be the hit sound. This needs to be the success sound. All right. So yeah, I copied the did once code for it because we already, for the instantiation of the particles, we set up a variable to make sure we only would do it once. So that was helpful because otherwise the clip is just going to keep repeating as long as we're in this state. Now I think we head out of it. No, we never head out of this state unless the Pokeball gets deleted, I think. Otherwise it just stays here because there's nothing to happen anymore at that point, because escape is never going to go through and like everything else is meh. So yeah, that's kind of what I did. I used to did once to make sure it only plays once, and putting all of that together leads to the following result. Oh, I forgot to mention, I actually added 5 PsyDucks. I put the timer to 300 seconds and their range of sight is a lot better now. Weep, weep. There you go. Success. And you can hear where they kind of are based on the size. So yeah, anyway, I'll do one more video after this where I wrap everything up. But yeah, this is going to be it probably for this video here. So yeah, I hope that was fun. Like, I think the game came out pretty nicely. Like, it would benefit from a bunch of things, obviously. It would be nice to have an aiming mode, to be able to do some more rapid fire, to have a nice little fence around it all. Maybe even do some updates to the audio even. But I think so far this game is actually pretty fun to play. So anyways, I hope you enjoyed making it to the point that we got so far, and I'll see you in the next video. Bye-bye.